Hello everyone and welcome once again to MJ's Maths and Stats. That's MJ Magic Studio to you. I am your host, your host, and as usual in the host mode, Mohit Jain. So we will start with powers of 2. How to check whether a number is divisible by powers of 2, that is 2 to the power n. Simply to check whether a number is divisible by 2 or not, we just need to see that last digit of the given number should be divisible by 2. That means that last digit should be 0, 2, 4, 8. But I have also said about 0. That means large digit should be divisible by 2, that is even number 2, 4, 6, 8, or it should be a 0. Now, this is 2 to the power 1. If we talk about 2 to the power 2, that is 4, then see the power is 2 here. Here we will see last 2 digits of the number should be divisible by 4 or last 2 digits should be 2, 0. This is the pattern we follow when we check for divisibility rule of 2 to the power n. Likewise, if it is 2 cube or 8, then obviously we'll check for last 3 digits. And last 3 digits should be divisible by 8 or last 3 digits should be 0, 0, 0, 3 zeros. Similarly, if we need to check whether a number is divisible by 2 to the power n, we need to check last n digits of the number should be divisible by 2 to the power n, or last n digits of the number should be, we should have n number of zeros. Now we will check for powers of 3. So for powers of 3, it is very simple. It should be sum of digits. Whether a number is divisible by 3 or 3 square 9 or 3 cube 27 or 81 whatsoever, which are the powers of 3, sum of digits should be divisible by these numbers. So if we need to check whether a number is divisible by 9, we'll just find sum of digits. If that sum of digits is divisible by 9, then the entire number will also be divisible by 9. Now we move to powers of 5. Powers of 5 and powers of 2 follows the same type of pattern. Like a number is divisible by 5 when last digit is divisible by 5 or we have a 0 at the end. 5 is square or 25. A number is said to be divisible by 25 when last two digits are divisible by 25 or we have double zeros at the end. Similarly, a number is divisible by 5 to the power n when last n digits are divisible by 5 to the power n or we have n number of zeros at the end of the number. Now is the time to actually learn very interesting things about the divisor, which is 7, 11 and 13. To start with, we'll start with 7. सबसे पहले the easiest of the rule is what I call is M2 rule. Now, how to use this M2 rule? First of all, use this M2 rule when the numbers are small, like 3 digits or 4 digits, something like that. Now, how to use this rule and what is this 2? What is this M2? Suppose we need to check whether 483 is divisible by 7 or not. What this rule says, M2 rule, 2, this is 2 multiplier rule actually. Deduct the last digit and multiply it by 2. So 3 into 2 is 6 and deduct 6 from the remaining digits. Then what you get is 42. Clear? Now we know that 42 is divisible by 7, which leads to this entire number 483 is divisible by 7. We can move it further onto it also. 2 into 2 is 4. If 4 minus 4 is 0, if we are getting 0 as a single digit or 7 as a single digit after subtraction, then the entire number is divisible by 7. What we need to understand is, you generally use this concept for small numbers of 3 to 4 digits. Let me take one more example. 7, 4, 8, 3. I just, you know that it is divisible. Minus 6 will give 742. Now 2 into 2 is 4. This will give us 70. Now we know the 70 is divisible by 7, then the entire number is divisible by 7. Now, one of the interesting rule for 7 is what we call code rule. For this, we just need to remember a code, and that code is -1, 2, 3, and then with alternative sign 1, -2, -3. Now, how to use this code? Let me take an example like 1, 3, 6, 9, 8, 5, 1, and I am checking whether this number is divisible by 7 or not. Use this code -1, 2, 3 from left to right. Clear? Write this as the coefficients with these digits in continuum, like -1, 2, 3, then we will alter the sign. 1, -2, -3, then we'll alter the sign and it will be -1. Multiply these with the respective coefficients and add up. So what we'll get, -1 into 1, -1, plus 2 into 3 is 6, plus 3 into 6 is 18, plus 1 into 9 is 9, -16, -15 and -1, and now we just need to add them up. So after addition, what we'll get? 18, 24 and 23, 22 and 9 is 31, -31 is 0. So either we should get a 0 or a multiple of x. If we are getting with a positive sign or negative sign, it hardly matters. If we are getting 0 or a multiple of x, then the entire number is divisible by 7, and this is the best rule to crack few questions where digits are missing. Like for example, if I say that a number 23x41 is divisible by 7, what is the value of x? In these kind of question, this code rule is of ultimate help. Like 23x41, if I use the code -1, 2, 3 and then 1 -2, I'll get -2 plus 6 plus 3x plus 4 -2 gone. I would be left with 3x plus 6. Now I need to find the value of x, which will obviously range between 0 to 9, such that when this value is put here, this whole number 3x plus 6 becomes either 0 or multiple of 7. So if I put 0, it is 6, 1, 9, 2, 12, then 3 is 15, 4 is 18, bingo. When I put x equals to 5, I'm getting 15 plus 6, that is 21. This becomes 21, which is multiple of 7. That means value of x is 5. That means 2, 3, 5, 4, 1 is actually divisible by 7. So in these kind of question, this code rule is of ultimate help. Next prime number divisor we have is 11. And here also we will learn two different simple rules. One more we can do. Let's see. First is M1 rule. Like we have used M2 rule for 7, for 11 and small numbers, if it is 3 or 4 digit, this is what you can use very easily. like 2871, and if you have understood M2 rule, M1 rule is similar. Delete the last digits, multiply it by 1, that means the same digit, and keep on deducting from the remaining number. So 7 minus 1 will become 6. Now 8 minus 6 will become 2. Now 2 minus 2 will become 0. So at the end, either you will get a 0 or any digit which is multiple of 11. Obviously, if we are remaining with any 2 digit, like if we end up 22, then there itself we can say that this number is divisible by 11. That is M1 rule. Okay. The second rule is the famous one which you can find in any quantitative aptitude book. That is sum of odd placed digits minus sum of even placed digits should be either 0 or multiple of 11. Like if I take an example, 4, 2, 5, 9, 8, 7, 1. Okay, now start from the left hand side and do skip addition. That is, leave one digit and add the other. 4 plus 5, 9. 9 plus 8, 17. 17 plus 1 is 18. Now add the remaining digits. 2 plus 9 is 11. 11 plus 7 is 18. Now subtract it. 18 minus 18 is 0. Or after subtraction, if you are getting any positive or negative multiple of 11, then also the given number would be divisible by 11. Now we can use one more method, that is pairing of digits from right to left. Let's check with this example itself. 4, 2, 5, 9, 8, 7, 1. This will go from right to left, pairing 71, second pairing 98, then 25, and then we have 4. Now we just need to divide this two-digit number by 11 and find the remainder. So 71, 66, 71, that is remainder would be plus 5. 98, remainder would be minus 1, because 98 will become 99 if we add the residue. That will be minus 1. 25 when divided by 11 will give remainder 3, and 4 when divided by 11 will give remainder 4. So now we just need to add them up. 4, 3 is 7, 7 plus 5 is 12, 12 minus 1 is 11. So if we are getting 0 or multiple of 11, then the entire number is divisible by 11. Now, rule number 2 is the best rule which is available in the market, but I try to follow this rule if in case, see the point, if in case a number is not divisible by 11, then this method will always help you to find the remainder. Like suppose I take any arbitrary number, 2, 9, 3, 6, 5, 4, 1, 7. Now, I don't know whether this number is divisible by 11 or not. And if it is not divisible, then what should be the remainder if this number is divided by 11? We make pairs. 17 will give plus 6. 54 will give minus 1. 36 will give plus 3. 29 will give either plus 7 you can write, or you can write 33 minus 29. That is minus 4. So what we are getting ultimately? 6 plus 3 is 9. 9 minus 5 is 4. Isn't it? Now, 4 is neither 0 nor divisible by 11. This means what? 4 is the remainder. 4 is the remainder when this number is divided by 11. That is the best part of this rule. Moving on to the next prime divisor, that is 13. And here again we have same two rules like we were using for 7 and 11. First is our M9 rule. Generally we don't use it. It's complicated because we need to multiply the last digit with 9. Still, let's see how it's done. 169, delete the last digit and multiply it by 9. It will be 81. Now subtract the remaining number from 81 or 81 from the remaining one, whichever is the bigger. So 11 minus 6 is 5 and this will be 65. Now we know that 65 is divisible by 13. It is multiple of 13. That means the entire number is divisible by 13. Use this for small digits, small numbers of 3 or 4 digits. The second rule, which is actually like you should be using this rule itself, is the code rule again. We have learned one code rule for 7, but a code rule for 13 is pretty more easier to remember. It is simply I love you and then alter the sign I hate you. -1, -4, -3. Or insert 1 plus 3 is 4, code is 1, 4, 3 and then -1, -4, -3. The working rule is same as we have seen in 7. We would be using from left to right. Let me take a number 2, 9, 1, 1, 2, 7, 2. Let's use this code from left to right on top of these digits one after another. 1, 4, 3, then alter sign -1, -4, -3, then alter sign 1 and stop. Now we need to multiply this and then add up. 2 plus 36 plus 3 -1 -8 -3 into 7, 21 and then plus 2. So 29, 30, you're left with 6 and 5, 11 plus 2 is 13. So either we should be getting 0 or multiple of 13, then the entire number is divisible by 13 and this is the best rule for 13. Now presenting a general rule for any prime number which end with 1. If the divisor is a prime number which end with 1, we will always use M rule, that is multiplier rules. Like if prime number is 11, we use multiplier 1, which we have already seen. Prime number is 31, we use multiplier 3. Prime number is 41, we use multiplier 4. For 61, we use multiplier 6. For 71, it is 7. For 101, we can use multiplier 10. And similarly, let me pick up few more. If a divisor is 131, your multiplier would be 13. For 151, multiplier is 15. 181, multiplier 18. 191, multiplier is 19. So any prime number which ends with 1, its multiplier is just delete 1 from the end and use it. And we know how to use multipliers. Now many would be in the confusion कि ये हो क्या रहा है और हो क्या गया. Suppose, let me take an example. Somebody asks 30597. We need to check whether this number is divisible by 31 or not. First of all, we know that 31 is a prime and we know that rule for prime number divisor ending with 1 is delete this 1 and this will be its multiplier. Now how to use it? Write the number 30597. 7 into 3, delete the rightmost digit or the last digit. 7 into 3 is 21. Delete 21 from the remaining number. We'll get 30 and this will be 38. Now we have 3038. 8 into 3 is 24. So this is 291. 13 minus 4 is 9, 7 and then 2. Now 7 into 3 is 27. When we deduct, we are getting 0. That means this number 30597 is actually divisible by 31. So if somebody asks you that how will you check or whether a number is divisible by these prime number which ends with 1, you use this M rule or multiplier rule. Now moving on to an exclusive part of this masterclass is how to generate a multiplier for any 2-digit number. Suppose, we'll try to see this. Suppose our divisor is a 2-digit number, AB. Then what we need to do is multiply AB by Q. We need to identify that Q such that after multiplying ABQ plus A, the leftmost digit, should be divisible by B. If we can do that, then ABQ plus A when divided by B, whatever is the quotient we are getting is the multiplier. Let's take an example. Suppose we are looking out for multiplier of 17. So multiply 17 by such a number that plus 1 is actually divisible by 7. That is the B. This is A and this is B. So now 17 into 2. 17 into 2 will be 34, and 34 plus 1 is 35, which is actually divisible by 7. Now 35 by 7 will give 5 as the quotient. The multiplier for 17 is 5. Let's take an example. We have a number, suppose 6103. We need to check whether this number is divisible by 17 or not. We know that multiplier is 5. 3 into 5 is 15. We need to deduct it. 610 minus 15 will be 600 minus 5, 595. Now 5 into 5 is 25. We are left with 4 and 3, and we know that 34 is multiple of 17. That means 6103 is divisible by 17 and the multiplier is 5. Let me repeat the process once again. Let us try to find the multiplier for 13. Okay, so now this is A and this is B. 13 into something should be such that which is divisible by 3 plus 1 should be divisible by 3. So 13 into 2 if I take is 26. If I add plus 1 it is 27, and bingo, 27 is divisible by 3. 27 is divisible by 3 how many times? 9 times, and hence the multiplier for 13 is M9. Let's check for 23. This is A and this is B. Multiply 23 with something such that when we add B, B in this case is how much? It should be, after multiplying, plus A is 2. Okay, so the rule is 23 into 2 if I do, I'm getting 46. I need to add A is 2, it becomes 48, and bingo. Is 48 divisible by 3? Yes, 48 is divisible by 3. How many times? 16 times. That means rule for 23 is M16. Let's do one more. We are trying to find multiplier for 37. This is A, this is B. Again the rule. Multiply AB by Q such that after multiplication plus A. 37 into 2 will give me 74. Plus A is 3. That is 77. Bingo. 77 should be divisible by B. B is 7. Yes, 77 is divisible by 7. It will give 11. That means multiplier rule for 37 is M11. You can practice this by your own and you can generate the multiplier of your own for any number which is like not in our comfort zone and we can't remember. Then these kind of rules would be very helpful. Now next phase is like how to check for composite divisors. Whatever we have done till time is for prime number divisors. Clear? For a composite divisor C, suppose, try to locate co-primes. Try to locate co-prime such that suppose we are locating two co-prime. C1 into C2 is C and LCM of C1 and C2 should be equals to C. And mind it, they should be co-prime. That means HCF of C1 and C2 should be equals to 1. If we can locate this, we can easily check whether a number is divisible by that composite divisor or not. Like suppose our composite divisor is 6. So let's find the co-primes of 6 co-prime number which should be multiplying and should be giving us 6, or in other sense LCM of C1 and C2 should be equals to C, that is R6. So in this case we have got what? 2 and 3. We can see 2 and 3 are co-primes, check. 2 into 3 is 6, check. LCM of 2 and 3 is 6, check. For 12 would be 3, 4. Now don't take 6 and 2. Why? For the same reason. Number 1, these are not co-primes because 2 is common between 2 and 6. Number 2, C1 into C2 is C, fine. But we should have all 3 ticks. LCM of C1 and C2 should be 12. LCM of 2 and 6 is not 12, it is 6. That means we are not getting tick in all the boxes. And obviously HCF of 2 and 6 is not 1. So we are not taking 2 and 6. We will take 3 and 4. Check. Co-prime? Yes. 3 into 4, 12? Yes. 3 and 4 LCM is 12? Yes. So this is how we generate the rules for co-prime. So if somebody asks you whether a number is divisible by 12 or not, we need to check for 3 also and we need to check for 4 also. Likewise, for 14, it should be 2 and 7. For 15, 3 and 5. For 18, 2 and 9. And now I give you a task. Please find what should be the rule for 24, 45, 72, 88, and do it. Good. So hopefully you all have understood how to find co-prime. So for 24, it should be 3 into 8. We need to check for 3 also and we need to check for 8 also. So a number is said to be divisible by 24 if sum of digits are divisible by 3 and last 3 digits are divisible by 8 or are 0, 0, 0, then the entire number would be divisible by 24. Likewise for 45, it should be 5 and 9. 72 is 8 into 9. 8 and 9 are co-primes. For 88, similarly, it would be 8 and 11. 8 and 11 HCF is 1. Check. Multiplication is 88. Check. LCM of 8 and 11 is 88. Check. This is how we generate rules to find for composite divisors. Okay, let us see few important cheat codes for algebraic expression and other kind of numbers, and this would be of help. Who knows where it will be, but can be of a great help. Like any 6-digit number of the form AAA, that means all the 6 digits are same. So any 6-digit number of the form AAA is always divisible by 7, 11 and 13. Similarly, any 6-digit number of the form ABC. So ABC can be any digit. Obviously A is not 0. And then ABC, this kind of numbers are also always divisible by 7, 11 and 13. So you can get a different kind of question based on this. Suppose it is given that 666 is written something like 92 times and this is divided by 7. Then what will be the remainder? Now we know that it is all digits are same 66666. We know that the pairing of 6 digits at a time is always divisible by 7. That means we just need to divide 92 by 6. When we divide 92 by 6, we get remainder 2. That means 666 written 90 times plus 66. This number can be written as 666 written 90 times plus 90 times into 100 obviously. 666 written 90 times into 100 plus 66. This is the number. Now we know that first part is divisible by 7. We just need to check that what is the remainder when 66 is divided by 7. So when 66 is divided by 7, remainder is 3. So answer would be 3. That 666 written 92 times when divided by 7 leaves remainder 3. So moving on there, cheat code number 3. For any even digit number, this is only for even digits. For any even digits number like 2-digit number or 4-digit number or 6-digit number, let me take an example of 2-digit number. When the reverse of the digits or reverse of the number is added to the number itself, this is always divisible by 11. And when it is subtracted from reverse of the digit, then the resultant after subtraction is always divisible by 9. You can see like 23, 32 is 55, which is divisible by 11. And 32 minus 23 is 9, which is divisible by 9. Moving on to the next one. And here we will consider a few algebraic expressions. Like a to the power n plus b to the power n, where these two n values same. A to the power n plus b to the power n is divisible by a plus b or factors of a plus b only when n, that is the power which is same, is odd. Like 13 to the power 7 plus maybe 14 to the power 7, it will be divisible by 13 plus 14, that is 27, or factors of 27. Similarly, a to the power n minus b to the power n is always divisible by a minus b, whether the power is odd or even, but the values of n should be same. It is not that it is 13 and it is 17, not like that. 13 to the power 7 minus 5 to the power 7 is divisible by 13 minus 5, that is 8. Clear? This power should be same. Or 13 to the power 8 minus 5 to the power 8 is also divisible by 13 minus 5, that is 8. Next one, a to the power n minus b to the power n is divisible by a plus b only when n is even. And for this property number 4, we can have an extension. An extension is very important. We have seen many good questions coming different examination. Extension is a to the power n plus b to the power n plus c to the power n till k to the power n, where the values of all n is same, is divisible by a plus b plus c till k, given that n is same and odd. This will be of great help. Let's take a timeout and try to solve this question. Pause the session and try to solve it yourself, and then look out for the solution. I hope that you have the answer by now. Let's see what we have learned in previous slide. And now, can I write my expression as 44 cube minus, I'm taking common minus, 36 cube plus 8 cube. Now this is a cube plus b cube. A cube plus b cube is divisible by a plus b. 36 plus 8 is 44. So if this expression is divisible by 44 and this is also 44 to the power 3, that means entire expression is divisible by 44 or multiple of 44, which includes 11. That means it is divisible by 11. Now let us do this. Can I arrange this as 44 whole cube minus 36 whole cube taken together minus 8 cube. Now a cube minus b cube is divisible by a minus b. 44 minus 36 is 8. That means this expression is divisible by 8 and this is also divisible by 8. The entire expression is divisible by 8. Okay, bingo. It is also divisible by 8. Now can I write this expression as 44 cube minus 8 cube taken together minus 36 cube. A cube minus b cube is divisible by a minus b. 44 minus 8 is 36. It is divisible by 36 and this is 36 whole cube. This entire expression is divisible by 36 or factors of 36, which includes 9. So that means the given expression is divisible by all of them. It is divisible by 8, it is divisible by 9, it is divisible by 11. It might be divisible by any other number also, but as far as options are given, it is divisible by 8, 9, 11. That means we'll mark on all. All of the given devices, all of the given numbers can divide the given expression without leaving any remainder. Okay, let's try this. Another one on your screen. As you know, please pause, try to do it yourself. And there are many questions of TCS Ninja and TCS Digital which I have already solved. The link will be there in the description. That is special questions which we have seen them asking in the previous TCS NQT Ninja Digital examination on divisibility rules. Please also go through it. The link is there in the description. In the meantime, please don't forget to subscribe to the channel. Please do it and let it grow. Solve the question. So hopefully you must have solved this and you must be having answer by now. Let's see what to do. A number is divisible by 72. 72 is a composite number. We need to find the co-prime divisors. So it is 8 into 9. We know. Now domain for 8 is smaller than domain for 9. 9 is like sum of digits. We need to check for 8. It is 2 cube. We just need to check for last 3 digits. That means 4y0 is divisible by 8. What can be the value of y? Okay, y can be 0. 400 is divisible by 8. And then we keep on adding 40 to it. Yes, 440 is divisible by 8. And then 480 is divisible by 8. So value of y which are possible are 0, 4 and 8. Got it. Now we go to check for 9. And the rule for 9 says the sum of digits should be divisible by 9. So sum of digit is 7 plus 3, 10 plus 4, 14. Sum of digit is 14 plus x plus y. Now if I take y equals to 0, sum of digit will become 14 plus x. Then what should be the value of x such that 14 plus x become divisible by 9? 14 plus 4 is 18, which is divisible by 9. So value of x is 4. Bingo. If y is 4, sum of digit will be 14 plus 4, that is 18. 18 plus x it will become. That means value of x can be 0. 18 plus 0 is 18, divisible by 9. And value of x can also be 9. 18 plus 9 is 27, which is also divisible by 9. So when y is 4, we can have two values of x, that is 0 or 9. Now when y is 8, then 14 plus 8 is 22. 22 plus x, value of x would be 27 minus 22 is 5. So how many pairs we have? First pair we have is 4, 0. We are writing in the form of x comma y. Then we have 0 comma 4. And we have 9 comma 4. And then we have 5 comma 8. So how many such pairs of x comma y are possible such that this number is divisible by 72? Answer is 4. Now different type of question can be designed on that. They can ask you what can be the biggest of such number which is divisible by 72. X, the highest value of x we got is 9. Then biggest of such number would be 5, 2, 9, 3, 4, 4, 0. Or what is the average of all such possible numbers which are divisible by 72. We know that we are getting 4 numbers. We can add up and then find the average of that also. So different kind of questions can be designed as per the difficulty level. But the actual process of doing this is on your screen. Do it like this. Now moving on to the last part on master class related to properties of different divisibility rules by different divisors. Let's see rule for few numbers in the pattern like 9, 99, 999 and so on. If we see that these numbers are of the pattern 10 to the power n minus 1. This is 10 to the power 1 minus 1, 10 square minus 1, this is 10 cube minus 1 and so on. Let me check and take a number like 9, 8, 3, 0, 4, 5, 6, 1, 2, 1. And somebody asks that find whether this number is divisible by 9 or not. We know that rule for 9 is sum of digits. Now there is interesting thing with these numbers that while we are checking for them, if we are not getting 0 or any number which is divisible by 9 when we are adding up, whatever we will get at the end after the digital sum, that would be the remainder. Like if I add them up, how much I'll get? 16, 17, 20, 24, 29, 30, 36 and 38 plus 1 is 39. So sum of digit is 39 and we know that 39 is not divisible by 9. Now if I do 3 plus 9, that is 12, and again 1 plus 2, that is 3. So the important part is 3 is the remainder actually when this number is divided by 9. So if I divide this entire number by 9, remainder would be 3. How to get this? Just find sum of digits and keep on finding the sum of digit till you get a one digit number. That one digit number, if it is not 9, then the number is not divisible by 9 and whatever you get would be the remainder. Now moving on this, let me take this number again, 98304561121. We have been asked to check whether this number is divisible by 99 or not. Now the rule here is how many 9s are there? 2 9s. Now from right hand side, from right to left, make pairs of 2 digits. Make pairs of 2 digits and add up. 9830456121. 8 9 15 1 6 7 9 10 13 16 25. So how much we are getting? 255. Again we'll repeat the same process. 2 digits and 2 digits. So it will be 0, 2 and 5, 5. We are landing up at 57. Now 57 is a 2-digit number. We will stop when we get the 2-digit number. 57 is not divisible by 99. That means what is 57? 57 is actually the remainder when this entire number n is divided by 99. This is the process to find and check whether a number is divisible by 99 or not. And in this due course, we can also find the remainder. Now if I take the same number again, 9830456121, and ask them to check whether this number is divisible by 999 or not, rule will be same. We will go from right to left and make pairs of 3 digits. 121, then 456, then 830, and we are left with only line, that will be 009, and then add up. So it is 9, then 830, 456 and 121, 10, 16, 1, 9, 10, 11, 1, 8, 9, 10, 14. Again we will do the same thing, 001 and 416. When we have a 3-digit number, we need to stop. If it is not 999, then the number is not divisible by 999 and this is nothing but the remainder. So if this same number n is divided by 999, we would end up getting remainder 417. So the pattern is simple. In case of 10 to the power n minus 1, we need n digit set from right to left, add up and keep up adding till you get a n digit number. If that is 999 coming n times, then the number is divisible, or else whatever you will get is the remainder. So moving towards the end of the session, let us take a few good numbers again, which are in the form of actually 10 to the power n plus 1. Previously we have done the numbers which are in the form of 10 to the power n minus 1. So 10 to the power n 1, 11 or 200 plus 101, 1001 and so on. And like how to do it? Let's take an example. 1, 2, 3, 4, 5, 6, 7, 8. I've taken an 8-digit number. We need to check whether it is divisible by 11. We'll follow the pattern. The pattern for this is alternative sum technique. Alternative sum technique, which is just adding all the digits from left to right with alternative sign. Suppose it is 11, so we would be adding up these digits with alternative signs from left to right. So it will be 1 minus 2 plus 3 minus 4 plus 5 minus 6 plus 7 minus 8. And what we'll end up getting is minus 1, minus 1, minus 1, minus 1, 4 times, that is minus 4. Now, 4 is not a multiple of 11. That means this number is not divisible by 11. Now, if I ask you to check for 101, it would be in the same format we have done for 99. In 99 from right to left, we were making pairs of 2 digits. For 101 from left to right, we'll make pairs of 2 digits. So it would be like 12, then opposite sign, minus 34, plus 56, minus 78, and we need to find its value. So it would be minus 22 and 122. 22 again minus 22. That is minus 44. Now 44 is not divisible by 101. This number is not divisible by 101. And yes, for the part you people were waiting for, like what is this minus 4, what is this minus 44, and somebody also asked me why we are doing from left to right. Logic. First thing, if we are doing from left to right, without this negative sign, whatever you are getting, leave this negative sign, whatever you are getting is the remainder. This is remainder 4 in this case, and here we'll get remainder 44. Suppose after adding up, after doing this, we are getting a positive number. Suppose we are getting 4, then that is not the remainder. Then the remainder will be 11 minus 4, that is 7. If after adding this up with the alternative sign, you are getting plus 44, then plus 44 is not the remainder. Remainder would be 101 minus 44, that would be the remainder, which you need to keep in mind very clearly. So this is what we have in part 1 of divisibility rule. We'll come with part 2 very soon, and stay connected. Do subscribe to the channel, and I'll come back very soon. I know I'm coming back after a long time, but this is Mohit Jain signing off from MJ's Maths and Stats at MJ Magic Studio to you. Stay well.